Right, so welcome to Pure 2 Chapter 5.2, where this lesson we look into arc length. Now, previous lesson we introduced what's radian. Radian is just an alternative unit to degrees. Okay, so we can measure angle in two units, degrees or radian. Okay, the conversion between degree and radian, to convert degree to radian, we divide by 180 times it by pi. From radian to degree, we divide by pi times 180. Okay, right. Or remember, 180 degree is 1 pi. Okay. Notes, arc length. We briefly mentioned about arc length last lesson. So arc length equals, so arc length, L. So L equal. So I use this little L. I like to write L this way. So L, because if I, it's not capital L because capital L means different things. Smaller L, if I write like this, it looks like a 1 and I. So L, I look right like a ribbon. So L equals R theta. We know this theta is in radians. Okay, so that's the arc length. You have to remember it. Okay, example. Find the length of the arc of a circle with radius 5.2, given the arc subtends at an angle of 0.8 radians at the center of circle. If you struggle to understand what it means, it simply means if you circle, okay, there's a radius in here, and the arc subtended at an angle means here and here, that's 0.8. Simply 0.8 radians. That's what it means. So how to find arc length? So arc length, L equals R theta, simply equals 5.2 times 0.8. It is what it is. 5.2 times 0.8. So put in a calculator, you get 4.16 centimeter. Yes, that's what it means. That's how we calculate. Example, next one. By the way, if you feel like you're confident to try it on your own, it's simply we're just playing around with this equation. Be brave, be courageous, and try to have a go at this example if you feel like, and then you can check your answer with me. That's a good thing about radius videos. Example, an arc AB of a length with radius 7 and a center has a length of 2.45. So that's the arc length. Find the angle subtended. So we know L equals R theta. The length is 2.45. The radius 7 times theta. So divide by 7. So 2.45 divided by 7 is, mental maths, just kidding, is 0.35. I'll put rats in here. 0.5 radians. Rats. Example, next one. An arc AB with center O has radius R, subtends an angle theta at O. The perimeter of a sector is AOB is P. Express R in terms of P and theta. So let me draw you that one. Okay. So it simply means this one is theta, this radius. Okay. And then once you work out the perimeter of the whole sector. So to find the perimeter, again, pause the video, try it yourself first. To find the perimeter, we know perimeter equals to R plus the arc length. And the arc length is that side. And how do you find the arc length? We know arc length, L equals R theta. So L equals simply R theta. So the perimeter equals to R plus R theta. So P equals to 2R plus R theta. And there's nothing else we can do. Oh, actually, there's nothing else we can do for P. But the question wants us to express R in terms of P. So we have to make R the subject. My bad. I should have seen it properly. So in here, to make R a subject, we can factorize R, 2 plus theta, divide 2 plus theta over P over 2 plus theta equals R. Something about me have to put a subject on the left-hand side. So I just put an extra step in here. So R equals P over 2 plus theta, right? Okay, so next one, slightly more harder. Again, read the question, let you have a go first. Even though it's an example, I'll let you have a go, see if you're able to crack it up. Okay, when you're ready, you can press play, right? Example, the border of the garden pond consists of a straight edge AB of length 2.4 meters, right? And the curved part C, as shown in diagram, the curved part is an arc of a circle. Center O, radius 2 meters. Find the, say centimeter, actually it should be meters, doesn't matter. Find the length of C. Right. If you've tried yourself, the final answer is 9.99 meters or centimeter. Doesn't matter. Okay, if you got it right, again, move on. But if you don't, let's go through. To find the length of C, okay, that's arc length. So arc length means R theta. To find the R theta, we've got radius, we've got 2. 2 is a radius. So radius is 2. So C equals 2 times theta. Now, in the question, you can see theta is being here. So how do we find theta? Well, we can find this angle in here. Let's call this x. Okay, to find x, well, think about this. How could we find x? There are different ways to find x. Okay, to find x, let me draw this triangle in here. 2, 2.4, 2. One way you can do is cosine rule. So method 1, you can do cosine rule. Okay, or method number 2, you can divide into 2 right angle triangles. Okay, and then use trigonometry. Use trigonometry or SOHCAHTOA. Okay, so method 1, if you use cosine rule, then you should have. Let me use. Okay, so if you use method number 1, okay, so cos x equals b squared plus c squared minus 2bc cos a, which is actually a squared. So left hand side is a squared. Sorry, my bad. So I haven't done cosine rule for a long time. A squared. So a squared equals b squared plus c squared minus 2bc cos a. Okay, then you can rearrange it, etc. So 2.4 squared should be 4.76 equals 4 plus 4, which is 8. So 8 minus 2, 4, 8. So 8 cos x. So 8 cos x, you'll be rearranging 8 minus 4.76 divided over inverse cos. So inverse cos of 8 minus 4.76 over 8. Make sure you put in a calculator. So if you put in a calculator, you should get, so make sure in radians mode, inverse cos of fraction 8 minus 4.76 over 8, 1.15. Yep, 1.15. So that's 1.15 rads. Okay, so that's x equal 1.15 radians. Now, if you want to do the other way around, okay, of course you can, which is dividing into 2 triangles and SOHCAHTOA. So method number 2, if you divide into half, okay, so we can find this angle here. We know that's 2, that's 1.2 in here. It's not x because it's half of x, so I'm going to use y. Okay, so I can use a different letter, maybe a, capital A. Okay, so that's opposite. That's hypotenuse. That's opposite. So sine A equals 1.2 over 2. So A equals to inverse sine of 1.2 over 2. So let's plug in the calculator. So inverse sine of 1.2 over 2, that's 0.6435. But that's half of its full angle. So x equals double of that. And if you not point times by 2, you get 1.29. Let me double check my final answer. I might have made a mistake. Be right back. Right, found it. Mentioned so many times, do not trust your mental maths because I made a fatal mistake in here. It should be 2.4 squared is 5.76. Do not trust your mental maths. That's dangerous in here. So hopefully it should fix everything. 5.76. 5.76. 8 minus 5.76. I use red because I should show you the mistake I've updated. So if I do that again, so inverse cos of fraction 8 minus 5.76 divided by 8. Yep, 1.287. So that's the same on both sides now. So 1.287. On the orange one, you also get x equals 1.287. So then what do we do next? So we found x. However, we need theta. So what's theta? Well, theta equals the full circle, which is 2 pi. We do use 360 because from radians, take away x. So that's 2 pi minus 1.287, which you put in a calculator. That's same as 4.996 radians. Okay, so therefore the C equals to r theta equals to, so C equals to radius times 4.996, which is roughly around 9.99 meters. And that's the final answer. Okay. Moving on, exam practice. Pause the video this time. Have a go on your own. Okay. When you're ready for the answer, you can press play. So this is the final answer for question A and B. If you got it right, well done, move on. Okay, but if you got it wrong, let's go through why, or let's go through working out. Question A, the length of the arc BD. So we know arc length. So arc length L equals R theta. The radius is clearly 8, and the theta they told you is 0.6. So 8 times, sorry, 0.7. 8 times 0.7 is 5.6 centimeter. Easy peasy. Okay. Part B, find the perimeter of R. To find the perimeter of R, you've got the arc length in here, and then you've got this part. Okay. So arc length, and you've got DC, and you've got BC. So the total perimeter equals to R plus the length of DC. Not R, sorry, not R. I mean the arc length. So arc length, we use L, sorry, L. L plus DC plus BC. Right, we know L, don't we? L is 5.6. And DC, now, AD is 8 because that's also radius. So radius. So DC, therefore, is 11 minus 8, which is 3, plus BC. So perimeter so far, we've got 8.6 plus BC. So how do we find BC? Well, to find BC, we can use cosine rule. So we have to use cosine rule. So we can use cosine rule. So imagine so look at the full triangle. Okay, we've got 0.7 in here, we've got 8, and we've got 11. So when we find this value x in here, so we can do cosine rule. So a squared, so a squared x squared equals b squared plus c squared minus 2 times b times c cos 0.7 cos a. Okay, make sure your calculator is in radians. Okay, so I'm going to plug the whole thing into calculator. So 8 squared plus 11 squared minus 2 times 8 times 11. Now my calculator is in radians. You can see R on the top, times cos 0.7, close the bracket. I get 50.37. That's x squared. So when I square root it, 7.098. So x equals 7.098. So therefore, that's BC. So therefore, the total perimeter is 8.6 plus 7.098, which is around 15.7 centimeter to 3SF. And that's the end of the lesson.